Hi guys, we're doing a video because I've been pulled into a meeting and I can feel I can trust you to do this on your own, but I thought maybe kind of walking you through it as if I was there might help you understand a little bit better. Obviously, if there's still a struggle when I return, we'll work on it. I'm going to split this up into 2 days anyway. So lesson 10 is true false statements or true false equations. They're in your book on page S49. So take a moment, maybe pause this real quick if you're not already on S49. It should have an M1 in the top corner. So the point of this lesson is now to understand that equations are actually statements of equality between two expressions, and that when we start substituting values into those equations for the variables, then we will be able to determine whether or not that actual equation is either true or false. And then we will look at the end, so probably Friday, being able to find values to assign to those variables that will actually make the statement true. So on S49, hopefully you're there, you have these 4 examples that we're going to look at, and you're going to think it's a little crazy because A and B ask you if they're grammatically correct statements, what's the verb, what's the subject, and then whether or not the statement's true. So keep in mind, we're talking about true and false statements. So I want you to understand that, yes, there is a value to this, not that we're trying to do an English class, not that I don't think it's horrible that we're doing a little English and math. So take about 5 minutes and then come back in and we'll talk about what we see here. So for A, you should have that, yes, it is grammatically correct. The subject is president, the verb is, and that, yes, it is a true statement. For B, yes, it's grammatically correct. The president of France is a United States citizen. The subject is president. The verb is still is, but the statement is actually false because the president of France can't be a US citizen. Just like you can't have a guy from France being the president of the United States and not be a citizen. So look at C and D. C, now we're actually substituting some math. So you have 2 plus 3 equals 1 plus 4. We're telling you right off the bat that this is actually a sentence. And that the verb of the sentence is actually equals, and the subject is 2 plus 3. So 2 plus 3 equals, and then here's your outcome. And then the question is, yes, it is true that 2 plus 3, which is 5, 1 plus 4 is 5, so 5 does actually equal 5. And then D, 2 plus 3 equals 9 plus 4. Is this a sentence? A statement, a sentence? Yes. Same thing, you've got your subject and your verb, but we know that it's actually false because 2 plus 3 does not equal 13. And like I said, it seems a little weird that we did some grammar with math, but keep in mind, I'm sure you've heard that mathematics is a language. And if not, I'm telling you now it is, that when we speak mathematics, we're actually speaking a language. It'd be just the same as when you read it in English. English is a language. If the language was French, we would be reading in French, and if the text were written in Korean, the language would be Korean. So when you're reading a math textbook, yes, there's some words, but even those numbers have a certain flow and a purpose and a way that we have to write them. Just like when we're talking about standard form versus just willy-nilly, there is a purpose to everything. So even though a sentence can be, just like we set up here, grammatically correct, it can still be false, just like in the number statement. Yes, we have a sentence, a number sentence, has everything it's supposed to have, but in the end it can be false. Not every statement that's written grammatically, whether it's in English or in numbers, is always true. So we're going to look through that. We have some definitions here at the bottom of your page. A number sentence is a statement of equality between two numerical expressions. So like 2 plus 3 is a numerical expression, 9 plus 4 is a numerical expression. It becomes an equation because we add the equal sign. And that in order for it to be true, which is the number sentence, is said to be true if both the left equals the right. So both sides have to equal the same number. If it's not, then we know it's false, and that is called a truth value. So when we assign it true or false, we're giving it an actual truth value. All right, so on page S50, we're going to have you start doing some math problems to determine whether or not the number sentence is true or false. If something looks tricky, obviously skip it and come back to it, but definitely try all of them. You are welcome to use a calculator. You are welcome to use your phone if you have your calculator on your phone versus the one in the classroom or on the Chromebook. Do what's necessary. So pause and then come back and we'll talk through a couple of these. All right, so an exercise 2, number A or letter A. Let's see if I can do math and English. So a letter A should have false. 12 does not equal 15. B is true. C is true. The commutative and the associative properties. Just because we group it differently and order it differently doesn't mean that it's going to get you a different number or a different value. E is false. F, this pi equals 3.14 is actually false because you should recognize that pi is a number that never ends. So this is just what we would do to shorten it, but that is not what pi actually equals. It is a number that will just keep on going. So that is why that statement is false. So if you said true, sorry, hope you understand why. G, this one is false. If you don't know how to do radicals, obviously we'll come back to it, but just a quick recap. 4 plus 9, you would do this, and which would give you 13, and then you take the radical or square root of 13, which will give you a decimal. It's not a perfect square. But 4 and 9 individually are perfect squares. So the radical of 4 is 2, and the radical of 9 is 3. And then you'd have a different number, which would be 2 plus 3, which is 5, and then the square root of 13 is a nice decimal, so that's why it doesn't equal each other. Hence why it's false. H is false. I is false. J is true. K is false. L is true. M is false. And N is true. So if you didn't have those, go back and check and maybe double check your math to see if you get those answers. And if you still have questions, obviously, you can ask me later. All right, exercise 3 is where we're going to end before I give you your task for today. So exercise 3, take a couple minutes and based on our conversation and what we just did, answer the two statements right here. So you've got A and B. So A says, could a number sentence be both true and false? And then B, could a number sentence be neither true nor false? And then for your answer, hopefully you have something where basically for A, no, they can't be both true and false. It's either or. So it's you either are going to be true or you're going to be false. There's not a situation where we can say, you know, -1 is going to equal 1 here, but it's never going to equal negative. They're not going to equal each other in another situation. No, a number is a number. And it's not going to suddenly have a different value and be something else in some alternate reality. And then when we're looking at where they could be neither true nor false, no, it's got to be one or the other. It still comes back to one or the other. Again, because you know you're assigning a value to a number and it represents something. So we're going to end here. We're going to come back to exercise 4 on Friday. But what you're going to do is you're going to go to the problem set, which is on page S55, and you're going to try numbers 1 through 12 only. 1 through 12 only for today. So 1 through 6, you're just trying to determine whether or not the statement is true or false, like what we just did. And then we're going to see how you do with 7 through 12. Even though this is something we're going to come to on Friday, let's work on substituting in and then determining what that value is. And once you get that value, then does that make the statement true or false? 7 through 12 get a little tricky. So again, if it's something that you feel you can't do, try to do some of them.